Hello students, we'll study about metals and non-metals, class 8. Here we will learn what is metal, what is non-metal, properties of metals, non-metals, chemical properties of metals, non-metals, and uses of metals, non-metals. Here you can identify few metals and non-metals which we are using in our daily life. Lead balls, you have seen ball bearings in your bicycle. Tin can, Coca-Cola tin. Gold ornaments you have seen. Platinum is also used for making ornament. Copper is used for making vessels. Even wire, conducting wires are made up of copper. This is nickel. It is used for making steel. Nickel is steel. If you say that steel is a metal, steel has the properties of metal, but it is mixture of metal. It is an alloy, mixture of metal and non-metal, which is carbon, is present in steel. Stainless steel is rust free. It does not show rusting. So steel, brass, you might be knowing pital. You are knowing bronze. The modern medals are made up of bronze, kasa. Brass, it is a mixture of metal, copper and zinc. Bronze is made up of copper and tin. Yes, copper and tin. So they are the mixture of metals. So mixture of two or more metals, sometimes non-metal, are called as alloy. Diamond, this is diamond. It is one form of carbon, as graphite is also form of carbon. Diamond is also one form of carbon. Phosphorus you have seen in the matchstick. This is yellow colored powder sulfur, and this is coal. Now you have to do this activity. Collect few samples of metals and non-metals and do the following activity. You have to check whether the metal iron nail, is it shiny in appearance or dull. You will find it shiny and it is very hard. Coal, dull and not very hard. On hammering it breaks, means they are brittle. Then aluminium wire, shiny. Aluminium foil you have seen, it is lustrous and hard. Copper utensils are shiny, brown color, brownish red shine, and it is hard. Here you can find out that sulfur is powdery, phosphorus is powdered, means they are dull and not very hard, they are soft in color. So metals are shiny in appearance and they are hard. Non-metals are dull in appearance and soft, powdery. Now we'll study the physical properties of metals in detail. First property is hardness and the strength of the metal. So metals are generally very hard. They have more strength. They have more tensile strength. Fine wires also have more tensile strength. Strong, they are solids. Generally they are solids. Iron is solid. Copper is solid. You have seen magnesium ribbon, that is solid. All these are solid. Zinc pellets also you have seen, they are solid. So generally metals are solid. Exception is mercury. Mercury is liquid. Then this is because why metals? Because metals are used for making more wires, because metals are in general hard and strong. For example, magnesium, aluminium and iron. Exceptions are there like sodium and potassium. They are very soft, solid, and they can be cut with knife. Mercury is exception. It is a liquid under ordinary condition. Non-metals, whereas non-metals, most of them are gases. Hydrogen, oxygen, nitrogen, chlorine, they are all gases. Helium, noble gases which are present in air, helium, neon, argon, all are gases. Most of them are gases, only few are liquids. Chlorine, bromine is liquid, brown color liquid. Solids are also there. Carbon is solid, sulfur is solid, Phosphorus is solid. So maximum, most of the non-metals are what? Gases. Few are solid and very few, that is bromine, it is liquid, brown color liquid. So you have seen sulfur yellow color, carbon black, phosphorus red, bromine brown. It means this non-metals come in variety of color, but iron, the fresh piece of iron is always silvery gray in color. Followed? Next property is lustrous. They shine, and this lustrous property is utilized to find out the to make ornament. Jewelries are why they are made up of metals, because metals are lustrous. They are shiny in appearance. Jewelry. So they have luster known as metallic luster. Aluminium, iron, zinc, copper, silver, gold are all lustrous. Such metals can be polished too. Silver can be polished by gold. Third property is sonorous. Sonorous means the metals produce ringing sound on beating, on hammering. They produce, that's why they are used for making metallic bells in temple, in your school also. Musical instrument, the wire, string of the musical instrument is also made up of the metals. So metals are sonorous. What does sonorous means? They produce ringing sound. When struck, they produce a sound called as metallic sound or metallic clink. Ringing of bell, or when you drop a coin, it produces the sound. That sound is the sonorous nature of metal. Next is ductility. Ductility means metals can be drawn into thin wires. Here you can see how thin wires are made up of metal. Iron, aluminium, copper, aluminium foil you might have seen, silver, gold, can be easily drawn into wire. This property is called ductility. Another property is malleability. What does malleability mean? Malleability means it is the property of the metal to be drawn, to be beaten into thin sheets, Then can you draw a wire from piece of a wood or coal? No. Why? Because they don't have strength, tensile strength nahi hota hai, because wood and coal are brittle. On hammering they will break, they are not flexible. Followed? Next is the metals are good conductor of heat and electricity. Metals allow the heat to pass through them easily. If you are, suppose this is a metal rod and you are heating from this end, the heat flows to another end. This is called as conductivity. Whereas if you burn a piece of paper is non-metal, it will catch fire. It does not distribute the heat all over. You can't use frying pan made up of cardboard. It will catch fire. Why? Because it is a bad conductor of heat. The fry pans are usually made up of metals. So utensils which are used for cooking food are made up of metal, aluminium, copper, all metal. Why? Because they are good conductor of heat and even electricity. So they are the good conductors. Insulators, what are insulators? They don't conduct electricity and heat. Water, glass, wood, air, plastic, vacuum, they are insulators. Next is electrical conductivity. You will perform this activity. You have done in earlier classes also. Testing electrical conductivity. Metals conduct electricity. So this is the source of electric energy. Bulb you are having, you will take LED bulb, and the wire. When the ends of the wire are connected with a ruler, whether the bulb glow or not, you have to note. Dry paper towel, bulb will glow or not. Wet paper towel, you have to see. Wet paper towel, water is a conductor of heat, electricity, so it may glow. Pencil, you have to sharp both the ends. So when the wire touches these pencil lead, which contain which non-metal? Graphite. So it will glow because graphite is a conductor of electricity. This is the exception. Or in case of non-metals, only graphite conduct electricity. Next is metals are good conductor of electricity. Such wires you might have seen in your home. These are the metal wire and it is covered, wrapped by insulator wire, plastic, PVC. Why? Because these are insulators. They prevent us from shocks. So they allow electric current to pass through them easily. Why? This is why the electricity is transported from one point to another, like those of copper or aluminium. Which is the best conductor of electricity? Silver, and then next is copper, and next is aluminium. You cannot use nylon or jute ropes for electrical transmission. Why? Because nylon and jute are bad conductor of electricity. So metals are good conductors. These are non-metal. Non-metals are what? Bad conductor of heat as well as electricity. They are insulators. Now in contrast to metals and non-metals, you have to differentiate between metals and non-metals. So metals are lustrous and non-metals are usually lustreless or they are dull, except graphite is shiny black, iodine is shiny violet in color. Metals are solid, but non-metals, if solid, they are brittle. Carbon is solid, but on hammering the coal breaks, so it is brittle. Bad conductor of heat and electricity, except graphite. Graphite conducts electricity. That's why it is used in dry cell as electrode. It is graphite is present in the pencil lead also. With that's why it conducts electricity. Non-sonorous, they do not produce metallic sound. So out of 24 non-metals, 12 are solid: carbon, silicon, phosphorus. Silicon is present in sand. Sulfur, 1 is liquid. Bromine is brown colored liquid. And 11 are gases: hydrogen, nitrogen, oxygen, fluorine, chlorine, helium, neon, argon. Hydrogen, what is the symbol? H. H is the hydrogen atom, but in nature it exists as gas. So what is the formula of this hydrogen gas? H2. Oxygen is oxygen atom, but in nature it is present as oxygen gas, O2. Nitrogen gas, N2. Helium, only atomic gases. Neon, atomic gases. Argon, atomic. Followed? So here two atoms combine to form molecule, gas molecule. Followed? This is molecule. These are also gases, but here they are in atomic state. In later classes you will study these in detail. Next is the chemical properties of metals. First is reaction of metal with oxygen. You have seen rusting of iron. How it occurs? Iron on reacting with moist air contain oxygen. Brown color rust is formed, which is iron oxide. The actual formula is hydrated because rusting takes place in the presence of moist air, the oxygen as well as water. So it will form hydrated iron oxide, Fe2O3 XH2O. So what is rust? It is hydrated iron oxide. So here you have to study the formula also. So what is the symbol of iron? It is Fe. When react with oxygen, it form iron oxide. This is rust. It takes place in case of moisture. The rusting process becomes faster. That's why the iron articles, iron rod, iron window, they are painted. Why painting is done? To prevent from rusting. So articles made of iron such as grill, fencing they are getting rusted because of the reaction with moist air. What is rust? It is reddish brown in color and is iron oxide. Iron oxide is basic in nature. Metal oxides, all metal oxides are basic in nature. You have seen burning of magnesium ribbon. So magnesium ribbon, when burns in air, it forms a white color solid, magnesium oxide, and you have tested also with red litmus paper. It turns red litmus paper blue. It means magnesium oxide is, what is the nature of magnesium oxide? It is basic in nature. So similarly, if you test this iron oxide, it is also basic in nature. So in general, what we can say that metallic oxide are basic in nature. Next is reaction of metals with non-metals. Reaction of sodium metal with water. Sodium metal vigorously reacts with water to form sodium hydroxide along with lot of heat, as well as hydrogen gas is also evolved. Sodium, the symbol of sodium is Na. When react with water, you know H2O, it form sodium hydroxide. This is sodium hydroxide. Sodium OH is for hydroxide, plus evolution of hydrogen gas is formed and heat is also liberated. This potassium with water, potassium hydroxide, what is KOH? It is potassium hydroxide, and hydrogen gas is evolved in this with the evolution of heat. So these reaction of sodium and potassium, they are highly reactive metals. That's why they are always stored in kerosene to prevent their reaction with air and water. Next is reaction of metals with dilute acid. So in general, what you can say that metals plus dilute acid, they form salt. Neutralization reaction you have studied earlier in class 7. So which salt will be formed? Metal salt, metal chloride in case of hydrochloric acid, sulfuric acid, metal sulfate, plus which gas is liberated? Hydrogen gas is liberated. So metal, on reacting with acid, dilute acid, it liberates hydrogen gas. In laboratory, hydrogen gas is prepared by reacting hydrochloric acid with zinc metal. So it forms zinc chloride plus hydrogen gas. Test tube, if you take HCl solution and put some zinc pellets over here, you can find out the bubbles of hydrogen gas. If these bubbles are collected and bring a burning matchstick near these gas, this gas burns with popping sound. Similarly, here magnesium, all metals, magnesium on reacting with HCl, it form magnesium chloride plus hydrogen gas is liberated. How will you test hydrogen gas? It burns with popping sound. Zinc gives hydrogen gas along with zinc sulfate on reacting with sulfuric acid, any acid. Zinc plus sulfuric acid H2SO4, it will form ZnSO4 plus hydrogen gas. If zinc reacts with HNO3, nitric acid, HNO3, it forms zinc nitrate plus hydrogen gas is produced. Followed. So in general, what we can say that metals give hydrogen gas when they react with dilute acid. Now next, metal, one of the property of metal is that it shows displacement reaction. What does displace means? To shift. So in a displacement reaction, a more reactive metal will shift a less reactive metal from a solution and where it is taking place. In previous reactions, you have seen that sodium and potassium metal is kept in kerosene. Why? Because they are more reactive. You don't keep iron nail in kerosene. It means iron is less reactive. Copper, we are using it freely. Aluminium utensils we are using, we are heating, we are using aluminium vessels for cooking. It means they are less reactive than sodium and potassium. Followed. So on exposure to air, iron get rusted. Copper also form basic copper carbonate. Aluminium don't get rust. So it means some metals are more reactive and some are less reactive. So more reactive metal will displace less reactive metal from its salt solution. For example, copper and silver nitrate. Copper when react with silver nitrate, which is most reactive metal. Copper is more reactive than silver, so it will displace silver. इसको धक्का मार देगा, तो क्या बनेगा यहाँ पे? कॉपर नाइट्रेट plus Ag. So from the reaction also you can find out that which metal is more reactive. Here you can see iron when react with copper sulfate solution, aqueous means it is dissolved in water, it form iron sulfate. Again in solution, the color of copper sulfate you have seen, it is bluish in color. Iron sulfate also last year you have seen in class 7, green in color. And copper, brownish copper deposit is taking place over iron nail. When iron is dipped in copper sulfate solution, what changes occur? This copper sulfate will change into iron sulfate, greenish blue color will change into green and brownish copper deposit will take place. From this reaction you can see that iron is displacing copper. It means iron is more reactive than copper. Now this activity is given in your book. Take 5 beakers A, B, C, D, E. In A, copper sulfate solution, and what is taken? In B, copper sulfate solution. In C, zinc sulfate solution, and in D, it is zinc sulfate solution and iron nail, and D, ferrous sulfate and copper. So here what is taken? Copper sulfate and zinc granule metal. In copper B, copper sulfate and iron nail. In copper C, zinc sulfate is colorless. Copper sulfate, blue color. It is blue. Zinc sulfate is colorless. And copper turnings, shiny copper turnings are taken. Iron sulfate, it is green in color, green and yellowish green like this. And copper turnings. In E, zinc sulfate, again colorless, and iron nail. So what changes you will see? Here you can find here this one changes. Copper is depositing at bottom and this is the colorless. Zinc sulfate is formed. So what will be the reaction here? Zinc sulfate plus copper deposit will take place. What reaction? Zinc sulfate and copper, brown color deposit. This is what changes are taking place. Copper sulfate is blue in color and it is colorless. In second, again what was taken? Copper sulfate, and it means what? Zinc is more reactive than copper. Here copper sulfate and iron nail. So iron nail, it forms here again copper deposition is taking place and iron sulfate, greenish iron sulfate is formed. It means iron displaces copper from its salt solution. So what is being formed? Iron sulfate, which is green in color, and copper. So here iron is more reactive than copper, that's why it is displacing. In the beaker C, zinc sulfate plus copper turning, no change. Why? Because copper, why this reaction is not taking place? Because copper is less reactive than zinc. Followed? So zinc is more reactive, means copper is less reactive than zinc. Iron sulfate and copper turning, this one D, no change. Why? Because copper, we have already seen that iron is more reactive. It means copper is less reactive than iron. So this displacement reaction cannot take place. In beaker E, again zinc sulfate and iron. Zinc sulfate, zinc is more reactive than iron. Zinc is more reactive than iron. If you take iron sulfate in a beaker, FeSO4, 6th also you can take, and take zinc pellets in it. So zinc will displace iron sulfate. It was green in color. Now it will form zinc sulfate plus iron. So in displacement reaction, what you can draw information about that, the more reactive metal will displace less reactive metal from its salt solution. Next, few more examples of the displacement reaction you can study. Zinc plus copper sulfate, what reaction is taking place? This is zinc sulfate and copper. Copper is deposited, it will deposit over zinc. Aluminium, this is copper sulfate. So aluminium is more reactive than copper, so it will displace. This is aluminium sulfate. This is aluminium sulfate and copper will be deposited. Iron plus copper sulfate. So iron is more reactive than copper, so iron is displacing copper and iron sulfate is formed, FeSO4, iron sulfate, all in solution form. In dry, it won't, displacement reaction cannot occur. Lead with copper sulfate, again lead is more reactive than copper, that's why it is displacing copper, and this is lead chloride plus copper is formed. Calcium bromide, this is double displacement here, both replaces, calcium replaces silver and silver is displacing calcium, so precipitate is form of silver bromide. So this double displacement you will study in higher classes. Next is reaction of chemical properties of non-metal, where we study the reaction of non-metals with oxygen. Non-metals form their oxide. You know, carbon on reacting with oxygen, what is formed? Carbon dioxide. You already know. Sulfur plus oxygen forms sulfur dioxide. Nitrogen on reacting with oxygen, it forms nitrogen dioxide. All these are non-metallic oxide, and if you bring a moist blue litmus paper, where from the test tube from where the carbon dioxide is being evolved, it will turn red. It means they are all acidic in nature. So metallic oxide, we have seen that they are basic in nature, but non-metallic oxides are acidic in nature. How can you test this? With the help of blue litmus paper. Solution of sulfur dioxide, if you don't have, you can bring moist litmus paper. Sulfur, in a test tube you can take sulfur and heat it. So what will happen? Sulfur dioxide, and bring a moist litmus paper on the mouth of near the mouth of the test tube, it will turn red. So blue litmus paper is turned red, it means they are what? Sulfur dioxide is acidic in nature. Acid rain, you might have seen acid rain, है ना? You have studied about acid rain. Acid rain में कौन कौन सी gases होती हैं? यही सब gases होती हैं. Non-metallic oxide. Reaction of carbon with oxygen. When carbon is burnt in air, it forms carbon dioxide and it forms smoke which contain carbon dioxide. It is acidic in nature, and the solution of carbon dioxide in water turns blue litmus red. Reaction of non-metals with water. Non-metals generally do not react with water. Rather, some non-metal which react with water, phosphorus, yellow phosphorus, it is stored in water. Why? Because it has very low ignition temperature. It burns in presence of air. If you take it out in the room temperature, it will burn. So that's why it is kept in water. So phosphorus is not reacting with water, isn't it? Which react air vigorously. Just a phosphorus, it reacts vigorously with air. That's why they are stored in water. So can you name that non-metal? It is yellow phosphorus. Red phosphorus you all have seen in the matchstick. So it does not react with air. It is also having low ignition temperature. That's why it catches fire just by friction. When you rub it, it catches fire. It means their ignition temperature is less. What do you mean by ignition temperature? The temperature at which the substance catches fire. Reaction of non-metal with dilute acid. They do not react with dilute acid. Now come to the uses of metal. Iron is used in making, machinery, building, car, motorcycle, ships. Many parts they are made up of iron. Copper for making electric wires and statues. Copper utensils also we have. Aluminium is used in making kitchen utensils, electric wire, etc. Gold for making ornaments. Silver for making ornaments. Uses of non-metal. Non-metal is very less. Use of non-metal is less in comparison to metals. 22 non-metals are discovered. We breathe oxygen. It is also useful. Oxygen we breathe. Without oxygen, no one can live. Sodium chloride is formed. It is obtained from the seawater, which contain chlorine. Nitrogen is used for making fertilizers. Coal is carbon, diamond is carbon, graphite is carbon. So all these are useful for us. So that's all for today. If you have any doubt, you can ask me in the comment section. Thank you.